Last time, we created a replace chain function that reassigns the blockchain instance's chain with an incoming chain as long as the chain is valid and longer than the current one. To make sure this function works as intended, let's add two tests to blockchain.test.js. The first test will ensure that the chain is indeed replaced if a given chain is valid as input. The second test will demonstrate that the chain is not replaced if it receives a chain of less than or equal to length. And then we can trust that the chain is replaced if it passes the validation checks, since we're already testing that functionality through our isValidChain tests over here. So first, let's add a new unit test that checks that it replaces the chain with a valid chain. So that's the message, it replaces the chain with a valid chain. Then we have our arrow function as the second parameter. In this test, let's make a new valid chain by adding a block to the second blockchain. So let's add a new block, and this time it can be anything. So how about goo for the string? And now for the second blockchain, it should have the Genesis block as well as this goo block that we just added. So this should be valid, and calling replace chain from the original blockchain instance, passing in the second blockchain chain should be okay. So if we call bc.replaceChain, and then we pass in the chain of our second instance, this should be valid. To assert that the replace chain function worked, we'll expect that the first blockchain's chain is now equal to the second blockchain's chain. So we're going to expect that the chain of our first instance is equal to that of our second instance. And as we save this test, we find another passing test in the command line, and we even see the log's message that it replaced the blockchain with the new chain. Great. Now let's add our second test that makes sure the replace doesn't occur if the blockchain receives a chain of less than or equal to length to the current chain. So in this message, we'll say it does not replace the chain with one of less than or equal to length. Now that message was quite long, but again, that is, it does not replace a chain with one of less than or equal to length. See if I scroll this over just a little bit, will it fit? And yep, barely, it just does. In this test, we'll make sure that the first blockchain chain already has some blocks within it. So we're gonna add to the original block instance this time, or rather blockchain instance, and add one block called foo. And now that the first blockchain has some length, the chain with the second block chain only has a length of one block, which is the Genesis block. So calling replace chain will not be valid if we attempt to do so on the original chain. So let's call bc.replaceChain and then pass in the chain of our second instance. And now this should be invalid since its array of blocks is one less than the array of blocks within the first instance. So this time we'll have another expect, but let's expect that the BC chain is not equal to. And to make it not equal to, we put a .not function within the middle. And then we say .not to equal bc2.chain. Now as we do so, notice we get another passing test, and then we even get the log that the received chain is not longer than the current chain. Excellent. All our tests have passed. And we also saw those helpful console logs. With our replace chain function completed and tested, let's move on to creating an application around this blockchain system that we've already created. This application will allow a user to interact with the blockchain via HTTP requests. And on top of that, we built a network around multiple blockchain applications, so that way we can have multiple miners updating one shared and decentralized application blockchain. In particular, this networking aspect will take advantage of the replace chain functionality we just added. So lots of exciting code to get to. Let's move on.